All right, college algebra, we're in quadratic functions and models. This is section 3.1b. These are problems that we didn't get on the other video. Like, for instance, this is number 11. Graph this function. Okay, and it's asking the vertex. So this is a vertex form. So right here's your x value. Remember, it's the opposite of that. So it's going to be -2, and then there's your y value, -3. So there's my vertex. I'm going to punch it in there. Okay. -2, comma, -3. Okay. All right, perfect. All right. Now we're going to graph this thing. Okay. Now here's what you got to do on graphing this. This one doesn't do the boxes. You're going to have to literally graph it yourself. So I'm gonna do that. Just click on this graph here, and it's a parabola. So I'm gonna do this, and so first thing I'm gonna do is I'm gonna go to. Well, let me move it down just a hair. I'm gonna go to that vertex, which is -2, -3. So -2, -3 is right there, and I click it. Now you notice if I move up or down, it's going to make this parabola. Well, first thing first, see this negative in front? That means it's concave down. So it's going to be going down. Now, what I can do to make this real easy is I could just put a value in for x. Because see, since this 1/4, it doesn't go over 1 down 1. It's going to go over 1 down 1/4. So we're going to have some fractions involved here. So I think what the easiest thing would be to find some value of x that would go in here that would make this come out to be a whole number. Preferably we want something here that's going to come out to be a 4 multiple. So this 1/4 will make it come out to be an integer. So let's see here. What if I put 0 in? 0 plus 2 would be 2, and 2 squared would be 4. So that'll work. So if I put 0 in, I can just punch it in the calculator, you know, basically. So if I do that, -1 divided by 4, and in parentheses, 0 plus 2 in parentheses squared, and then -3, and then look there, I get -4. All right, so that means if I go to this next point, 0, -4 right there, that's a point on my graph. And that should do it. Check my answer here. Good job. All right, so literally, I just put 0 in for x, work that out, and there's my second point. So you do your vertex, which is -2, -3, -2, -3, and then plug 0 in to get the other point, and bam, that's all you got to do. Now the axis, all right, the axis symmetry is x equals, on your vertex, -2. So x equals -2. Okay, fantastic. And then domain, all right, every one of these is -infinity to +infinity. So -infinity to +infinity. Okay, nice work. And the range, now the range is what's different. Let me scroll this. You can see this thing goes down forever. But it goes up to that value right there, which is -3, which is included. So I'm going to do here, parentheses, -infinity. Well, don't need two of them. And then I'm going all the way up to -3, which is the highest value, and I'm going to put a bracket on that because -3 is included. All right, good deal. Now, here we're doing largest open interval, which the function is increasing. Increasing as you go from left to right. Increasing goes up. And this right here is increasing right there. Because as we're going from left to right here, this is going uphill. And it stops right there at my vertex. So it goes from -infinity on x all the way up to -2 on x. And increasing and decreasing never has brackets. It's always parentheses. So we're going to do -infinity to -2. Nice work. And now decreasing. decreasing as you go from left to right goes downhill, which is what we're doing here. See, as we go from left to right here, this is going downhill. So it starts right there at -2 and it goes all the way to infinity. So right there. Okay. So we're starting at -2 and we're going all the way to infinity. All right, good job. And there's that one. Okay. All right, we did this one, so we're going to go to 17. There's 17. All right. We've got here. I'll tell you what. Let me just draw this one. I'm not doing a very good job on my drawing, but I think you'll get to understand the idea. Okay. Let's get this out of the way here. We'll bring in my drawing. Here we go. Perfect. Perfect. All right, so we know this is the vertex right here. So we know right off that this function of x is going to be x plus 2 squared and then plus 3. Okay. Now, we know there's got to be some kind of multiplier because first this is going down, which means it's going to have to be a negative right there because it's going down. But it could be a multiplier like 1/4, like the one we just did or something. So what we're going to have to do is we're going to take this point here. Okay. And we're going to put these values in for x and y. So here's my x right there. I'm going to put a 0 for my x. And f of x is y. So I'm going to put -1 right there for y. And so here's how it looks. And I'm going to solve this equation and figure out, well, hold on. I didn't put that in there. And figure out what this multiplier is. So there's got to be some kind of multiplier here. I left that part out. So I'm going to solve this and figure out what that multiplier is. So first thing, I'm just going to subtract this 3. Okay, that's -4 equals a. And then 0 plus 2 would be 2, and 2 squared would be 4. Okay. And so I'm just going to divide by 4, and that's -1. There you go. There's what a has to be. So that means my function of x is going to be -1, and then x plus 2 squared plus 3, and really I don't have to have 1, just a negative. Okay, so I'm going to type that in here. So let's bring it back. Okay, and let's see right here. It's going to be negative, and in parentheses, I'm going to have x plus 2. Okay, and it's going to be, squared, and then plus 3. Fantastic. All right, 18, we're going to do it too. Got the cord in the way. And it's the same thing. It's the same thing here. So let's let me draw it out, and we'll do the same routine here. So my vertex is -5, 4, and I've got this point here. Is that -1, 0? Okay, there we go. So again, since we know this vertex right here, it's going to be y, or f of x, equals x plus 5 squared plus 4. It's going to be that. But we got this other point on here, and it's going down, so we must have a multiplier here. Okay, so I'm going to go ahead and put it in first off this time. And so I'm going to do the same thing I just did. This point right here, I'm going to put -1 where x is, right there. And right here where y is, I'm going to put that 0. And I'm going to solve this and figure out what this a number is. Okay. All right, so I need to subtract 4 on both sides, and that gives me -4 equals, all right, now let's see here, a times, all right, this is -1 plus 5, which is 4, and 4 squared would be 16. And so I divide both sides by 16, and that's a -1/4 is a. There you go, there's my a. So this is a 1/4 right here. Okay, so it's going to look like this. Y, or I'm going to put f of x because I think it's f of x on here. And it's going to be negative 1/4, and I have x plus 5 squared plus 4. That should be my answer right there. Okay, so I'm just going to put that on the screen. Let's see here. And we said this was negative 1/4. Okay, and then here we had a plus 5. All right, we got the plus in there, see? And this is a plus 4, and the plus is already in there for that. And well done. All right, good deal. I'm on a roll. I'm on a roll, baby. All right, 19. Yeah, we're doing 19 here. All right, in this one that says there's 760 feet of fencing available. And then we got this road here. Okay, so here's this road. We're going to have this fencing here. This is X, and that's X. We have 760 feet of fencing. So if I have X of it here and X of it there, how much do I have left for this? Well, it's going to be 760 minus those two X's. And that's what this first thing is asking for right here. The length of the remaining side. All right, that's going to be 760 minus 2 X's. Excellent. All right. Now, here you go. Here's the values of X should be such that X is between what? Okay, well, X has to be greater than 0. So we're going to put us a 0 here, which is saying 0 is less than X, which means X is greater than 0. Okay, now, since this X is the same as that X right there, as this thing gets bigger this way, it's going to get shorter that way. Okay, does it make sense what I'm saying here? See, as these two here get bigger, that's going to make this shorter, and this is going to come together. So, whatever this one is what that one is. So if I take my 760 and divide by 2, which is, what is that, 380? X has to be less than 380. Okay, so basically X has to be greater than 0, and then you divide it by 2, because you got these two here. It's got to be less than 380. Okay, now the area of this, all right, look at this here. Okay, I can't draw on the pad, so I got to move it out of the way. Area is length times width. Okay, my length is this 760 minus 2x, and my width is the x. So basically, I'm going to be multiplying these two things. And I distribute this x here, which is going to be 760x minus 2x squared. There's my area right there. Okay. Oh, sorry. I distribute the x. 760x minus 2x squared. That's my area. So I'm going to put that in here, right there in the box. I'm going to put in descending order though. Negative 2x squared plus 760x. You don't have to put in descending order, I don't think, but I'm going to. What did I do here? Oh, I put equals. I didn't even see that. I didn't hit my shift very good. Okay. I hate to see an X on there, man. Shoo. All right, now, this is saying right here, for what values of X is the area between 20,000 and 50,000? Between 20,000 and 50,000. All right, so let's bring this back up here. This is my area. All right, so what I'm going to do is I'm going to let my area be 20,000. Let's put it in descending order. And I'm going to let it be 50,000. Okay, and I'm going to solve both of these. So I'm going to have to minus 20,000 on both sides to make it equal 0. So that gives me this right here, and I don't have any terms to go together, so that's what I have there. And so I just do the quadratic formula. Okay, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So my a is negative 2. That goes here and here. My b is 760. We got that here, and we've got it here. And we got this negative 20,000 way over here. Okay. And then you work this out here. Let's see. This is going to be negative 760. This is negative 4 down here. And I'm going to go ahead and punch all this in. So I got 760. Put it on the screen here. Squared minus 4 times negative 2 times negative 20,000. And I'm going to do the square root of that answer. All right, 646,2197. I'm going to leave 4 decimals on there for my calculations now. I think the answers here are 2 decimal places, but I'm just going to do this for the calculation. So, okay. All right, here's my first answer. 28.45 looks like. Okay. And then we'll do the other one, negative 760 minus 646.2197 equals, divide by negative 4 equals, and I get 351.55. Okay, let me get on the screen here. Sorry about that. The light glaring on my screen here is kind of hard to see, and so all right, so there's this one I went through. I'll have this one on the screen as I do it. So I'm going to minus 50,000, and same thing as 0, negative 2x squared plus 760x minus 50,000. And so I'm going to do the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, my a is negative 2. That goes here and here. B is 760. 760 here, 760 there, and I got negative 50,000 over here. Okay. So that's negative 760. Down here we got negative 4. Now I'm going to punch this in. So let me put this on the screen here. And let's see here. I got 760 squared minus 4 times negative 2 times negative 50,000. Okay, and then do the square root of that answer. And here you go. 421.4261. I'll leave those 4 decimal places. So, all right, so I got plus 421. I'm going to minus 760. And I'm going to divide by negative 4. There's my first answer right there. 84.64. The 3 does not make the 4 go up. And I'm going to do the other one. All right, so I got negative 760 minus 421.4261, and then divide by negative 4. And I get this right, 295.36. Okay, so what this means is this, guys. To have an area in this parking lot between 20,000 and 50,000. Okay, that means I need X to be between these 2 values here or between these 2 values there. Because when I do 20,000, I get these 2 answers. When I do 50,000, I get these 2 answers. So X would have to be between these or between those to to get this areas. All right, so I think we got those answers on here to choose from. Let me scroll this. There you go. All right, so again, what we had here, let's put it on the screen here. You can see it. So it's got to be between 28.45 and 84.64. All right, it's got to be one of these last two right here, right? And then it's got to be between this and this. So 295.36. Right here, this D. D for Dave. Well done. Well done, Dave. All right, now, the area is maximum when the width is what and the length is what? Okay, let's go back to the thing here. All right, when we do this area right here, see my formula? See how this is negative 2x squared? That means it's a parabola that's going down. And my vertex up here is the highest value. So basically, for this problem, to figure out the maximum area, I want to figure out what the vertex is. All right, well, hey, man, I'm going to do that right here. I think I have enough room right here. Because all I got to do is x equals negative b over 2a. This is my axis of symmetry. Okay? Which means on this problem, my b is 760 and my a is at negative 2. So they're supposed to be in the opposite order. That's why I changed them down here, you know. So you're looking at negative 760 divided by negative 4. All right. So that's going to be positive 760 divided by positive 4. Same thing, 190. X has to be 190 to get the maximum area, which means this is 190 right here. And then 2 times 190 is 380. 760 minus 380 would be 380 right there. And that's the dimension that's going to give you the maximum area. And if you multiply those, there's your 72,200. That's your maximum area right there. Okay, look here. Let's say, hey man, what if this was 191? That means this would be 191, right? Which means this would be 378. So what would I get if I did those two? Look, check it out. 378 times 191. Look, it's a little bit less. See that? Can you see it? What if I say, all right, let's make this 189. And that'd be 189. Which means now this is going to be 382. Okay. All right, so 382 times 189. Look, it's a little less. See that? The max area is when x is 190 because that's the vertex. So let's put it in here. The max area is when the width is 190 and the length is 380. Excellent. And that means the maximum area is going to be, we just had it, 72,200. Fantastic. Okay, here's number 20. Okay. A piece of cardboard is 2.9 times as long as it is wide. It is to be made into a box with an open top by cutting 2-inch squares from each corner and folding the sides up. Okay, I did that earlier. I made this little piece of paper and I cut the corners out. See, like they're showing on here. And then you fold these sides up. So let me do this real quick. Now this is not perfect because I just did this in about 2 seconds while ago cutting this up. But at least you can get the idea of what we got going on here. See, look at my box here. Look at that, man. Ain't this cool? Huh? Wow. three-dimensional box. That's what we're doing in this picture. We're going to cut these corners out 2 inches and fold them up and make an open box. Okay? So here, let me draw this thing out. Okay? We've got this open box right here, or this is the bottom here. We're going to cut these corners out here. Okay. All right. So this is X. It says the length is 2.9 times as long, so this would be 2.9x, and I think that's what the first thing's asking right here, the length. 2.9 times x. There you go, that's right. Okay, give the restrictions on x. All right, now think about this a minute. X right here, since I'm cutting 2 off this corner and 2 off that corner, x is going to have to be greater than 4. No doubt about it. X has to be greater than 4. Okay, because if it's 3, if this is 3, then how are you going to cut 2 off each end? You can't. So it's got to be 4. It's got to be greater than 4. All right. And so now the length of the box. Okay. Here's my picture. I'm going to go back on there. This thing kind of split up on us now. But the length and the width. Okay. The length, we said a while ago, is 2.9x. So it's going to be 2.9x. But we got to subtract off 2 from each side of the length. So it's going to be 2.9x minus 4. Which means the width here, which is x, the width of the box is going to be x minus 4. There you go. Okay, does that make sense? The length was 2.9x, so the box, once I fold the box up, it's going to be 2.9x minus 4. See here, as I made my box a while ago, let me fold it back out. See, this was 2.9x right here, this whole thing. Once I cut these corners off and fold this up, now this is not going to be 2.9x no more, this length here. It's going to be 2.9x minus these 2 2's. 2.9x minus 4. All right, now the volume. All right, let's bring this back over here. Okay. So we're going to have this. Here's my box once I made it. All right. So this is going to be 2.9x minus 4 is how long that's going to be, because I'm going to take this 2 out and this 2 out, so it's 2.9x minus the 4. This right here is going to be x minus 4. All right, now what's the height of this thing going to be? Well, it's going to be 2, because we cut those 2-inch corners out. So the volume is length times width times height. Okay, so my volume is going to be 2.9x minus 4 times the width, which is x minus 4, times the height, which is 2. Oops, get it on the screen there, Dave. So now I just multiply these out. So like right here, I'm going to put a box underneath this. I'm going to put this x minus 4 over here. I like to do this box too. You know, you can do FOIL method, but I think the box is doing FOIL method. I think it organizes it for you though. This would be 2.9x squared. This is negative 4x. This is 9 times 4 is 36. 3, 8, 1, 11, 16, negative x. Okay, I just did the multiplying into my head there, hoping to confuse you. See here, 2.9, whoops, 2.9 times negative 4, see there, negative 11.6x. All right, and then I like doing the box because, see, afterwards these two go together. You put the right things together. And so I'm getting this, 2.9x squared minus 15x, I'm sorry, 15.6x plus 16. That should be my volume right there. Okay. Bring it in here. I'm going to plug it in this box here. So I've got 2.9x squared, space over, minus 15.6x plus 16. Okay. Oh man, what did I do wrong here? Oh, ignorant. My 2. I didn't multiply my 2. I just multiplied those 2. I forgot to do the 2, so I got to multiply all these by 2. So that's not there yet. 5.8x squared minus, what would it be here? 2, 12, 31.2x plus 32. I think 2, 1, 31. There you go. I think that's it right there. That's my volume. Forgot to do the dang thing. So, see, man, everybody makes mistakes, don't they? Good thing we can do this 3 times. 5.8. 31.2. Okay. All right, nice work. Nice, nice, nice. Okay. For what dimensions of the bottom of the box will the volume be 320? Okay. So, that's what this is asking. If this is my volume right here, then what does x have to be if this is going to equal 320? Oops, okay. So I'm going to set this equal to 320. That's what it's asking. What dimensions of the bottom of the box will give the volume 320? All right, so this is quadratic. I'm going to have to minus 320 on both sides, which gives me 0, 5.8x squared minus 31.2x. And this is negative 288. Okay. So I'm going to punch in the quadratic formula. All right, let me see here. I'm going to do this on the calculator real quick. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, I got these answers right here. I've got negative 4.85, can't have negative, that's out. I got 10.232163. That one we can use, it's positive. Okay. So that's what x is. Okay, I'm moving it out of the way because all right, here, I'm right down here. My length, if you remember, is 2.9x minus 4, and my width was x minus 4. So I just put that in. So, can get a calculator here. So if I put that in for x here, 2.9 times 10.232163. Now I like to leave these longer and don't round them once I put this in, because I might be the rounding might make a little bit difference. Minus 4 here. I'm getting 25.67. This is rounded to the nearest tenth, so 25.7. There's my length right there. And then I'm going to put it in right here. 10.232163 minus 4. So I get 6.2. That's my width. This is my length. And that's my width. And that's going to give me a volume of 320, like it's asking for. So if I put this in here, my length, as I just put it on there, 25.7, and my width would have to be 6.2. All right, well done. All right, now this problem just keeps going. Find the values of x such that a box to have a volume between 400 and 500. So what we're going to have to do is the same thing we just did on this problem a minute ago. I've got this volume. It's 5.8x squared minus 31.2x plus 32. That's my volume. So what values of x makes the volume between 400 and 500? So I'm going to have 400 equals 5.8x squared minus 31.2x plus 32. And I'm going to have 500 equals that. Okay, so we have to minus 400 on both sides. We just did this on the previous problem. So we have 0 equals 5.8x squared minus 31.2x. And that's going to be minus 368. Okay, and I'm going to do quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Alright, so let's put, we'll go Christmas here with red and green. My A is 5.8 right here. Right here. My B is negative 31.2. And my C is negative 368. Alright, which gives me this. Positive 31.2. Down here I got, what is it, 11.6 plus or minus. All right, let me put this in the calculator here. 31.2 squared. I'll just put positive since it's squared. It's going to be make it positive, so I just went and did that. Minus 4, and then 5.8, and then the negative 368. And that gives me this. Do the square root of that answer. All right, 97.5245. Okay. All right, so I've got plus 31.2 equals divide by 11.6, and I've got this right here 11.09 round to the nearest tenth, so 11.1. Okay. Now, 31.2 minus 97.5245 equals, oh crap, what did I do? 31.2 minus 97.5245 equals, okay, it's going to be negative. See there, it's negative, so forget that one. So you got 11.1 here. Now do the same thing for that one. Alright, so I'm going to minus 500. I got 0 equals 5.8 x squared minus 31.2x. That's going to be minus 468. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. You like these Christmas colors? You like the Christmas colors here, the red and green, since it's, you know, close to Christmas. My A is 5.8. My B is negative 31.2. My C is negative 468. Okay. So X equals positive 31.2. Down here we got positive 11.6. And then in my radical here, alright, let's see here, 31.2 squared minus 4 times 5.8 times negative 468, and then do the square root of that answer. Well, crap, what'd I do? Square root of that answer. 108.77. Okay. And if I minus this, it's going to be negative like the last one was, so I'm not going to bother doing it. So I'm going to add 31.2 and divide by 11.6, And that gives me 12.1. So 11.1, 12.1. So x has to be between these two values to get these two areas. All right, so 11.1, comma 12.1. Excellent. That is it on that problem. Man, that was a long problem. Challenging though, challenging. All right, we're at 21 here. 21 we're not going to do. We've already done that one. We're going to skip over 23. So let's go bam, bam. 23 right here. All right. To find the value of c so that this has one x-intercept. Basically what you're going to do is you're going to complete the square. Okay? So here's what we're going to do. What does this c here have to be for this to have just one solution? Well, we take our b term, divide by 2, and then square it. My b term is -6. I divide by 2, which is -3, and then I square it, which is 9. It's got to be a 9. Okay, when I have that, when I have this right here, this is a perfect square, so it would be x minus 3 squared, which has just one solution, 3. So here's another one. Suppose it was this. Suppose this was it. All right, well, I take my 16, divide by 2, which is 8, then I square it. 64. C would have to be 64 on this one. And that gives us this, x squared plus 16x plus 64, which is x plus 8 squared. It's a perfect square. Anyway, my answer is 9 for that problem. So that's how you do this. You just take your b term, divide by 2, and square it, and that gives you a perfect square trinomial. All right, so 9. Right. All right, 24. Solve this inequality by using graphical method. Okay. All right, let's do this. Okay, we got x squared minus x minus 2 is less than 0. We'll put a little bit of red in here and make it Christmassy. Okay. All right, well, this is less than 0. So basically, if I graph this, all right, this thing will factor x and 2, x and 1, and this goes to the big one. There you go. There's my factor. So here x equals 2, x equals -1. There's the solutions for x. Okay? Which means this right here. X equals 2 is a solution. X equals -1 is a solution. All right, see this right here? It's a positive x squared. That tells you it's concave up. So that tells me my graph is going to look like this right here. There's what this graph is going to look like, something like that. But it's got these two solutions. Now, the whole thing is, see here? When is this graph less than 0? Well, here's 0 right here. When is it less than 0? All down here. All this. Between that -1 and the 2. Between those two values, or in this interval. -1 and 2. So there you go. Okay. All right, here's another one. All right. Let's you like this Christmas theme? We'll stick with it, man. 4x minus 15, I'm sorry, 4x squared, greater than or equal to 4. Okay, so I need to minus 4 on both sides, so it can equal 0. So 4x squared minus 15x minus 4 greater than or equal to 0. Okay, let's do quadratic formula this time. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, my a is 4. My b is negative 15. My c is negative 4. All right, so that means I've got right here, negative 15 is 15. 2 times 4 is 8 down here. And my radical, I'm going to punch this in. 15 squared minus 4 times negative 4. Look at that, 289. And the square root of 289, square root of that answer is 17. Okay, 17. Which means I have this then. 15 plus 17 is 32. 32 divided by 8 is 4. 15 minus 17 is negative 2. Negative 2 divided by 8 is negative 1/4. There's my two values of x. Okay, which means this. Here's 4. Here's negative 1/4 right there. Okay, go back up to my drawing here, or my function. See how this is positive? This thing's concave up. Okay, and now when is this thing right here greater than or equal to 0? Greater than. All right, here's 0, remember? Here's 0 right there. Here's greater than up here. Those two parts. So on this part right here, it's all the way back here in negative infinity up to this 1/4, negative 1/4. And it includes it because it's got that equal to line. So there's one part of this. Then it picks up right here at 4, which we're going to include in that. And it goes all the way to positive infinity. And that should be my interval of when this is greater than 0. Greater than or equal to 0. So let's type in here, we got parentheses, negative infinity, comma, negative 1/4, space over, and put the bracket. And then I'm going to do a union. And then I've got another bracket here, and I've got 4 to infinity. And parentheses there, and let's hope we're right. And look at that, good job, good job. Man, I'm on a roll. I'm on a roll now. Missed that one a while ago, but I'm okay. This is 26. This is the last one. Aren't you glad? We're on 48 minutes right now. Let's move this over. We got negative x squared plus 2x plus 2 greater than or equal to 0. Now look here, it's negative, which means it's concave down. Concave down this time. Okay. It's already equals 0, so x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, my a is negative 1, b is 2, c is 2. All right. So that means I got a negative 2 here. 2 times negative 1 is negative 2 down there. And my radical, 4 plus 8 is 12. Okay, radical 12. 2 times 6, 2 times 3. We got a pair of 2's. 2 radical 3. So here's what we got. Negative 2 plus or minus 2 radical 3, all divided by negative 2 down here. Okay, so all these right here divide by negative 2. Since this is a negative 2 down here, we want to divide it by negative 2. So that means negative 2 divided by negative 2 would be a positive 1. 2 divided by negative 2 would be negative 2, so it's plus or minus negative 2, which is minus or plus positive 2, so it's still the same thing. I'm sorry, 2 divided by 2 would be 1. So it's 1 plus or minus radical 3. So basically what happens here, 2 divides all that, it's just be 1, 1, and 1. But the negative down here turns that to a positive, but it turns this from a positive to a negative to a negative to a negative and a positive, which is the same thing. So it should be 1 plus or minus radical 3, which is what we have over here now. We got right here 1 plus radical 3, and over here 1 minus radical 3. Okay, now remember this, it's concave down. Okay, and then look here, when is this greater than or equal to 0? Right here. See, here's 0. It's greater than 0 right there, and it's equal to, so we're going to have to include these endpoints. So basically, this right here, this is from 1 minus, see, 1 minus radical 3 to 1 plus radical 3, and we're going to have brackets on it. And that should be my answer there. So let's type it in there. See if it's right. The last one. Let's get this last one right. So we've got a bracket. 1 minus radical 3, space over, comma, 1 plus radical 3, space over, bracket. I think it looks good. Nice work. Nice work. So that's all for today, guys. This is section 3.1b. And if you have any questions, just give me a holler. You let me anytime, all right? Have a good rest of the day.